Welcome to the video notes for lesson 2-5. This is all about compound inequalities part 2, which is solving compound inequalities. If you remember from the previous lesson, we learned about what compound inequalities are, how to write them, how to graph them. Now we're going to deal with how to solve them. So we are on page 16, and you should see the same examples on your page that are on the screen. So we're going to talk about what a solution for a compound, or for an inequality in general, and then we'll deal with compound inequalities. So the first one, is 3 the solution to the inequality? Now, one way to answer this is, alright, let's go ahead and solve it. So I'm going to draw my train tracks, or draw my line down just like I would. I'm going to go ahead and distribute the -2. So I have -2x, either plus -10 or -10 is greater than or equal to 5x plus 23. I'll add 2x to both sides. You can solve this whatever way you wish. And when I do that, I get -10 is greater than or equal to 7x plus 23. Subtract 23 from both sides, -23. Okay, and we get -33 is greater than or equal to 7x. So last step, divide both sides by 7. And you get -4 and 5/7 is greater than or equal to x. I don't really like writing my inequalities this way. I usually like to write them with the variable first. So I'll do x is less than or equal to -4 and 5/7, and I'm writing it a little neater. So does 3 fit this? No, it does not. Now the other way we could have solved this would obviously be doing the check. So you can substitute the value in. So I'm going to go ahead and do that. Now I'm only going to use the ISS because it's an inequality, and we're not worried about checking our solution over here that we have. We're checking this actual number to see if it makes this inequality true. So we've got -2 parentheses x plus 5 is greater than or equal to 5x plus 23. So notice what I did is I rewrote the original inequality. Now I'm going to substitute 3 in and see if it works. Now we already know what's going to happen. We know that it should not work. But this will kind of be a check to prove that it doesn't work. -2 times 8, is that greater than or equal to, and then I'll do my 5 times 3, which is 15, plus 23. Now, last step, -16 greater than or equal to 38. And this is obviously not true. Okay, so is 3 a solution to the inequality? No. Three is not a solution for this inequality. So why not? Well, when you solve it, the value that you get when you solve the inequality 3 does not make that true. And if you substitute 3 in and do the check, it doesn't work. Alright, so now let's take a look at compound inequality. So we've got negative parentheses x minus 8 is less than 9, and x over 5 plus 1 is less than or equal to 2. Alright, so we have a compound inequality. It has and. We could actually combine these together if we wanted, but I'm going to just go ahead and solve both of them. So let's solve the first one. So negative x minus 8 is less than 9. So go ahead and we'll distribute the negative sign. So we have negative x plus 8 is less than 9. I'll subtract 8 from both sides. You could have added x to both sides, and I'll show you why that might have worked well in a moment. Again, negative x is less than 1. You're not done because we don't want negative x. I'm going to divide both sides by negative 1. You could multiply by negative 1 if you want. But because it's a negative, I have to flip my inequality, and I get x is greater than negative 1. Okay? So here's one part of our compound inequality. X is greater than negative 1. Is 3 greater than negative 1? Yes, it is. So far it's true. Now let's solve the other one. So I'm going to rewrite it. I've got x over 5 plus 1 less than or equal to 2. Alright, so first step, subtract 1 from both sides. X over 5 is less than or equal to 1. Now multiply both sides by 5 to get rid of the fraction. Or divide by 1/5, but that's the same thing. And you get x is less than or equal to 5. Is 3 less than or equal to 5? Yes. So is 3 a solution to this compound inequality? Yes. 3 is greater than negative 1, but less than or equal to 5. Okay. So we're going to see some better examples of this on the next page, but you get the idea. So we're going to be, and then, you know, another way we could have done this is we could have tested both of these inequalities with the ISS test, not with the ESS test. So I know that some of you who despise doing the checks, I've got good news for you. When we solve these compound inequalities, we do not need to do both checks. Oh, there's an interesting thing. If 5 of you come and remember that statement and share it in class, then I'll give you up to 5 points on your scoreboard. So one more time, you do not need to do both checks, only the ISS check. Alright, so let's take a look at page 16. So here we have a compound inequality that's written in set builder notation where it's all together. Now, we need to break this up so that it's 2 inequalities. By the way, this is an AND inequality. So, one of the inequalities that we would have is negative 3 is less than or equal to 3 over 2 x plus 6. And the other one would be 3 over 2x plus 6 is less than or equal to 3. So you'll notice what I had to do is, the first one, I took everything from the inequality on the right over, and then the second one, I had to take everything from here over, going that way. Alright? So that's how you split up a compound inequality that is AND. Alright, so now I need to solve them. So I'm going to go through and subtract 6 from both sides, and I get negative 9 is less than or equal to 3 over 2x. To get rid of that fraction, I'm going to multiply both sides by 2/3. You can divide by, hold on. Okay, so you could divide both sides by 2/3. or multiply both sides by 2/3, or excuse me, divide both sides by 3/2, or multiply by 2/3. When I multiply this side by 2/3, I get just x. Now this is not a negative number, so the inequality stays the same. -9 times 2/3 gives me -6. So one part of my compound inequality is -6 is less than or equal to x. Okay, now the other one. So I'm going to do the same steps, subtract 6 from both sides, and I get 3/2x is less than or equal to -3 this time. And again, multiply both sides by 2/3. And when you do, you get x is less than or equal to -2. And again, I didn't multiply or divide by a negative number, so the inequality stays as it is. Alright, so x is going to be less than or equal to -2, but greater than or equal to 6. So now we're going to put this back together in set builder notation, which is -6, my smaller value, is going to be less than or equal to x, which is going to be less than or equal to -2. We could also do the interval notation, -6, comma, -2, square brackets because it's also equal to. Now, we need to, if you look at the directions, it says solve the inequality and graph the solution. So, draw a nice straight line. We could do all of, you could put a nice scale on here. If you want to do a much simpler graph, the easiest way to do it, put your minimum value, your upper value, okay, and then the best thing to do is either get a different color, or I actually, when I'm making these graphs, will use pen to draw the graph and then pencil to actually do this part. I know some of you like to hover it above. That works well also. Alright, so there's the graph. Now, we are not done. We are also going to do a check. Now watch this. Very important. Check. Okay, it's an ISS check only, and we are going to be checking this compound inequality. So, -6 is, or excuse me, not this one. We're going to use this one to check the original one. That's what I meant. So we've got -3 parenthesis, or excuse me, less than or equal to 3/2x plus 6 less than or equal to 3. Now, what is the value that is in between -6 and -2? Now I noticed that my fraction in here has a 2 as a denominator, so I'm going to use an even number to be 6, so like -4. So watch what happens. So now I substitute -4 in for x. -3 is less than or equal to 3/2 times -4 plus 6 less than or equal to 3. So, -3 is less than or equal to 3/2 times -4 is -6 plus 6 less than or equal to 3. Now what's -6 plus 6? 0, of course. So -3 less than or equal to 0, which is less than or equal to 3. Is this true? Yes, it is. So the check worked. Lovely, isn't it? Okay. There is an OR problem below. You do not have to split this one up. It's already split up, but you're going to solve it just like we did. You're going to do 2 solving, but now think about how your graph is going to look different. And how your final answer. Now this time when you do the check, unfortunately you'll have to do 2 ISS's because there's 2 inequalities down here to go back to. But that's okay. When you finish, if you have any questions, make sure you see me or a friend for help, or your parents. Remember to share what I said earlier in the video if you want to earn some points on your scoreboard. Good luck, and we will see you in math.